Okie doke. Yay. And so let's see how we can we'll stay here with JavaScript. So let's see how we can use these last 30 minutes before lunch to get a pretty good hint about how to write Java code. As we're going to do after lunch then. But what do we need? Anything more basic understanding of JavaScript? So I said something like you know how an array works. So no, yes, no, yes, you know. So, yeah, I guess. So I have an array with numbers. I said type of, so type of this was object. Okay, yep. And then I have, let's have another thing. Yes, so let's make an object. Could I have that? Object x is 12. Wonder if I could do this. A is 24. Yeah, it worked. So type of B, object. So we have an array and we have an object. So this array is just a it is a collector of values. I could I push something to this array? Maybe. Hi, could I push it? Let's see what the array contains. Yes, I could. So let's push something else to the array. 42 is equal to 42. Let's push the result of that operation. It got to the item 6. Let's see what's in the array. Yeah, so it's true. It's a Boolean value. So an array, basically an array in JavaScript, can contain, it is not typed, so it contains a value, list of values, and it has positions. Obviously, the first one is 0, and the last one would then be 6. Nope. 5. Yes, the last one is 5. How many elements do we have in the array? A dot length 6. Okay? Yeah?
What would the object of this then be?
Type of A is an object.
So, okay, this array is not an object.
No, it's that is a sort of a. I shouldn't say it's a bit messed up, but it's a very rough structure of how JavaScript interprets types and objects. So this is an object, and and this what we have there, this B, that was also an object. Oops. So that was also sort of on this type level. It's called, yes, it's just an object. And but these two, array is also corresponding to a JavaScript global object with a capital O. So we could see that if I clear the screen and we stick with this array, I I could say that A is an instance of array. And you see capital A. Yes, it is. A is an instance of object, capital O. Yes.
Always capital, yeah, they're not primitive.
Yeah, so here we have capital O for these JavaScript built-in global objects. And is it a function? There is a global built-in for a function. No, it's not. And if we do the same test with B, where we have this type of it was an object. Okay, low level. What is B is an instance of object. Yes. And then there is no other sort of global object that it's within. Is it a global instance of a number? Nope. Is it a global instance of a string? Nope.
Sorry, wouldn't everything become an object?
Yes. And that is the basics. If you think of an object hierarchy. Yes. And so the object with capital O, it's on top.
Yeah.
Everything is an object in JavaScript.
As in Java also, right?
Pause. Yeah. So object is the everything descends from this capital O, and then we have number, string, array. We have something for regular expressions. So we have some basic object in this object structure, and these are not sort of, you shouldn't think of those as types, because they are more of a it's a function. Yes, it's more of a library. So we have let's see if we have I think we need to go here. Oh, here we go. So if we look at one of these sort of global objects, let's take the number. It is an object in the JavaScript object hierarchy, where object is top, and then we have these numbers, strings, and so on. And it's a container for many of the built-in methods or constants. So we have function or method to check if a number is really an integer. If it's not a number, we can go to also the object math, contains math functions, expressions, constants to work with math expressions. So these global objects, it's more of a sort of holder for, let's go here, MDN, number, or no, MDN JavaScript number. Let's go there. So it's a global object available for everything, and we have sort of this is what are the built-in. Let's see, here we have something to the left. Is finite, is integer, is safe integer, parse float, parse int. It's not too many methods built in, but there are some. So we have these global standard built-in objects. And we have them, let's see. Here we have some for numbers and dates. Number, math, date. We have for strings, and so on. So it's not it's a bit different. It's hard to compare this structure with another language that I know of before. So let's stick with, we can check up a type with this. When the type corresponds to an object, we can see if instance of is an array to check it up what type it is according to. And then we can have this use built-in functions like we had. Do I have an A? Yes. So let's pull something from A. Pull, push, pop, pop, pop. Let's pop something from the array. Oops, true. Pop.
The last one would out.
Let's see. Yes, the last one was out. What is to have the first one off? Is that shift, perhaps? Let's see. So, I shifted. Yes. So I shifted the 1. Let's shift the number 2. Yes. Let's pop high. Yes. And the array contains 3 and 4. So these shift and pop would be a property of, let's see, array. What can we do with an array? Yes, array has a property length, and then we have these. You usually find these methods that I'm using, shift, pop, push. They are called array.prototype, and then we have it, find, flat, for each, includes, join. There we have pop. And then we'll get a sort of a description on how to use it. Okay, type of, instance of, global objects, holder of built-in methods and functions. Yes. Let's see how. So let's see how many slides I went through now. I talked about number. I talked a bit about string. Same setup as number, just the other methods you are expecting. Type conversion. Let's have a quick example on type conversion. You know, this is not a, this is interpreted. So if I have A equals 1 and I have B equals mic, I could do A plus B, I would get 1 mic. I could do A plus B plus A, I would get mic 1. So this is, if you look at this, and you are sort of used to hard typed languages, this is not that hard typed. So you can do basically anything with variables. They have a type when I check it, depending on what its value is. But it's not defined as a sort of typed variable. So I can do anything with it, basically. Let's see what the slide said. Yeah. So if you think it's odd to do like this, if you think that's odd, well, yeah, it's odd, but that is how we could do it in here. Mic.true, I wonder what that becomes. Michael plus true. Yeah, so it's sort of, this is a string plus a string. Okay, sure, I can do that. And in this example, this is a this is a number. So let's have a number and then interpret this as a number. So 1 plus 1. And here it becomes a string instead. So that is just how JavaScript works with this sort of soft handling of variable content. It is not uncommon for loose type languages to work like this.
But if it was strict then?
If it was strict, same, yeah, same, yeah. So it's good to be aware of that. This is how it sort of could. This is just how it works. We can if we want to be a bit certain, we can ourselves parse from one sort of number to string, string to number, which is not uncommon to do that. We can just leave that. We have a Boolean. All these things would sort of turn out to false. So false, 0, an empty string, not a number, null, undefined, all those will turn out to a false value. Everything else is a true value. And if you remember, we talked about it and 1, the string 1 is equal to the number 1. Yes, it is. It is, however, not Jesus Christ. It's, however, not exactly the same because they differ in the type I have. So this is why you should always use a triple equality operator when you work, not only in JavaScript, mainly you do that in all these loose typed languages, like, well, PHP, for example. You can see from that example how they work. If not, well, we'll leave it anyway. So, let's have a checkpoint. There we go. I'll just skip through the array part here. Delete, truncate loop, around it, array methods, we did that. Let's see a bit about functions before lunch. So let's take the last minutes to review the functions. So I think I have 8 or 9 slides just showing off how a function could look like in JavaScript. So this is pretty straightforward. This is an ordinary function. It's declared, it has a name, and it's sort of available in the global scope. So we define the function in the global scope and we can call it later on, just like this, and get the value of it. Okay, that was, okay, I got that. How many of you have write functions like this? Some of you have done it. If you're doing it in JavaScript, it's common to do this. So this is another setup. It's called a function expression. So here we deal with the function as a whole expression, and we are sort of assigning this expression to that variable square. So it looks the same when I call it. It's just another way, and it's called function expression. And Java has it, PHP, C#, so a lot of programming languages. You can deal with functions in this way. Work with them as variables. Here is another one. It's a nameless function or anonymous function. It's assigned to this. It's basically an event handler. What should happen when I click on this element? Well, then you should call this function. So here we call it nameless function. It's still a function expression. This is also how we add event listeners. So let's do that. Check that out after lunch. So adding event listener on the click event on this element. And when someone clicks, let's call this sort of callback. We can call it a callback, but it's just another function expression. It's an expression which is a function. Whenever you see this, let's call it a CFEEF. It's an immediate invoked function. So it is a function expression. There it is. Let's see it. So it's a function expression. It's just in the sort of global scope, so it's just out there. And when the parser hits it, we wrap it with this. We wrap all that within these parentheses to make it, well, treat this as a complete expression now. And then we call it. We call the function immediately. So when the parser comes to this sort of setup, it will actually call that whole function immediately without leaving a trace in the global scope. Doesn't sort of create the named function. It just executes the code in it, and the code within it, it will have its own scope there. It's rather common to sort of see this type of setup in JavaScript. So it's good just to remember, oh, that's a function that's invoked immediately when it's sort of read in by the browser. Okay, so let's just see how the basic arguments to a function work. So we create a function like this. Let's send 3 arguments to it. Just return the sum of it. We may return something. We don't have to return something. And 1, 2, 3. So that one would return 6. And this one returns not a number. It's good also to know when you calculate, when you do a math expression in JavaScript, and for some reason it's perhaps, I don't know, something is wrong with it. It will just turn up to not a number. So it's a JavaScript constant saying not a number. So that is also a sort of a troubleshooting area for a JavaScript programmer. Once you have sort of a large code section and it eventually only shows up with a saying variable equals not a number, then you actually just have to backtrack it and see what was not a number in this, when did it sort of fail. So no errors sent. The expression just turns to not a number. I couldn't calculate it. Let's see one more. We can have, this is a way to work with default argument. It's not actually a default argument because it looks the same like last function. It had 3 arguments in. It is just how I treat, these arguments when I sort of set up my function. So I provide them all. Give them the actual argument, or if the argument was not there, give me a default value for it. So I make my function a bit more resilient, and now I can work it with 6 or 3. So this is a common way to see how people deal with incoming arguments and providing them default values. Let's have another one. Wow. Perhaps a bit. This is many languages has this type of construct. Here you see we send no arguments into it, and still when we are using the function, we send a lot of arguments, so it still does work. So this is just an example showing that there is a built-in variable or array that is sort of collecting all the arguments sent to the function. So if you don't want to mess up, if you don't want to actually put them here, you could just walk through the arguments array and work with it. It's common in many languages to have such a setup. So, yeah. Okay. And the object I did, and I think I'm going to do the I think I'll give you some short example after lunch, and I show you how this code actually works. So lunch for now? Yes, good.